Hey everyone, my name is Yograj Sikka. I am student of Center for Global Education at Chitkara University under the academic guidance of Deakin University, Australia, Melbourne. Today I am going to talk about the QUIC protocol here. The QUIC protocol stands for the Quick UDP Internet Connections. It is a modern protocol that is designed to make the internet communication faster, smoother, and more secure. We use the internet every day for browsing the websites here, watching videos, sending messages to each other, using cloud services. In all these, speed and reliability matters a lot. Where Quick is one of the protocol that help us to improve the experience and improvise our experience for viewing the videos, sending the messages. So in this presentation, I am presenting about the Quick, presenting about what is the Quick, why it is created, how it works, and how it look like in the Wireshark. So it will connect it with the networking modules we had studied in this unit, that are module 1 introduction to networking, module 2 which is application layer, and module 3 which is transport layer. So now let's move on to the slide and cover our part. So this is the presentation overview. As you can see here, here firstly I will explain the basic of the QUIC, like what, why, and network stack. So after that there I will talk about why it was needed and what was the problem to solve it. After that I will cover the main features, handshake, packet structure, and header types there. After that I will compare QUIC with TCL, TLS, and HTTP/2 and HTTP/3. So after that I will explain the HTTP/3 real world. After that there will be a real world application, its advantages and limitations, security features, security analysis like threats, migrations, etc. After that I will talk about scalability and their performance. After that, in the end, we will done a practical session or the practical analysis on the Wireshark demonstration. So now let's cover this. So as you can see here. So you what do you know what exactly is QUIC? So the QUIC is a transport protocol that runs over the UDP protocol instead of TCP, but it adds many things that UDP normally doesn't have, because it will improve our reliability, security, stream handling, etc. So in simple words, it tries to combine the speed of UDP with the useful features of the TCP here. So as we know all, is why QUIC is considered a modern transport protocol, because it is built of the current internet, where people want website to load fast and the connection stay secure. So it is the foundation of HTTP/3, which is the latest version of HTTP here. So when we use the modern website like Google and etc., QUIC will be working behind the scenes even if we don't notice it. So this is from my side. You can see here in the flow, like application layer of the HTTP/3, then it will go to the QUIC, then UDP, then IP. So this is my workflow from there. So now let's move on to the next slide. So the another thing we had to understand is why QUIC was needed here in the first place. So traditional internet communication here often used TCP with TLS on the top of it. So that worked, but it had some problems. It still had some problem. Like one of the major problem there was the slow and the was the delay between the during the connection setup. So as you can see, there is a three-way handshaking. Firstly, they will handshake and then the multiple rounds of trip will go on. So TCP first needs its own handshake, then TLS need another security handshake. So before actual data start moving, the connection already takes the time. So another problem is a head of line blocking. So that means if one packet gets delayed or lost, other data may get stuck waiting, and there will be not a ideal modern website, video streaming, or mobile apps. So the QUIC was designed to reduce the delay and get all the improve performance and solve these older limitations in many way, like extra handshake delay will be improved. So as you can see here, there are many solutions there. We can do the combined handshake, built-in encryption, which will give us security integrated with TLS 1.3. After that we can give the independent streams, like packet loss only affect one stream there. After that there is a connection migration and the user space implementation. So now let's move on to the another slide. So the another slide is about QUIC in the network stack. To understand the QUIC properly, it helps to see where it fits in the network layer. So on the top of it, you can see the application data goes through the transport layer, then to UDP, then to IP. QUIC sits in the transport area, but it includes some security and the control features there that older transport did not handle as neatly. So as you can see here, the application layer is the top layer, and it is directly connected to QUIC, which is in the transport layer. So after that, it is giving data to the network layer, then data link layer, and then to the physical layer. So they will get it connected. It is connected to our module 1, which is about introduction to networking, which is about understanding protocol layers and data flow across the internet stack. So after that, quick so you know the quick is very interesting here, because it is a simple transfer protocol, but it also impacts how application like browsers and video platforms performs. So the slide here connects directly with the networking concept we had studied in the unit like module 1 and module 3. So now let's move on to the next slide, and you can see here there are the main features of the quick. So let's discuss about the main features of the first. It is built on UDP. So as you know that it is a flexible and allow us to deploy it more easily. Second, it is built in encryption with the TLS 7.3 that supports security is a part of the protocol from the start to the end. After that, the third thing is support multiple streams, which means different parts of data can move independently there. After that, the another major feature is connection migration. After that, that means if your device changes from Wi-Fi to mobile data, the connection does the necessary breakdown immediately. This is very useful on laptops and phone as well. So after that, also quick is usually implemented in user space rather than the deep inside there. So this makes updates easier and faster to deploy and use. So overall quick is designed to be faster, safer, more flexible for modern use. So the next slide is quick handshake process. So in this slide we will discuss about the quick handshake. How does this happen on the different protocols? Like now let's talk about the handshake. Because this is the most biggest advantage of the quick. So in the older protocols, a connection setup can make multiple steps. As you can see in the traditional TCL plus TLS steps, it will take many steps. Like first it is synchronizing, then the acknowledgement is coming with synchronization, and after that there is the acknowledgement given by the user or the client to the server. After that the client will say hello, after that server will say hello, and then then the connection will finished. As you can see here in the quick 1 RTT, you can see there is the much more improvement in that. So quick improves this by combining the connection setups. It has combined their connection setup and encryption so that they will work more efficiently there. So after that, the new for creating every time creating a new connection, it often use the round trip, and after that returning user it can use zero round trip in some situation like zero RTT. You can see here in the image as well shown above. So if we say in the simple words, the quick starts faster, and for the modern web usage, faster start time is very big advantage for the user and the big advantage for the browser which will be showing that. So in this time, this is the most important protocol. So after that, the next slide is about the quick packet and frame structure. How the quick is getting packed and how its frame is structured. So the quick communication is organized using the packets and the frames. So let's discuss about the packet types. The packet is like the outer container. It will contain, and the frame is a container inside. So, some packets types are initial, handshake, 0 RTT, 1 RTT. In 0 RTT, there will be early data from returning clients, and there will be a reconnection. Phone usage phase is the reconnection. In the initial, in the initial packets are used at the beginning level. Handshake packets helps establish the secure communication over there. 0 RTT is for returning the connections. 1 RTT is used for the protected application data packets and to make the connection successfully established. And inside these packets, Quick was very different, like frames like crypto, stream, After that, acknowledge, padding. So crypto frames during the handshake, stream frames during the carry application data from one place to another place. After that, acknowledgement frames, which confirms the script or the which confirms the script or the receipt given by them. So after that, padding is just a extra space which will be needed use there. So after that, this is we had mentioned something like others are connection, close, reset, stream, max data, etc. So there are many more, but I had discussed all the major ones and the most important ones there. So this is the structure. Quick manage both security and transfer in a cleaner and more efficient way. So the next slide is about long header and the short header. So Quick mainly has two headers, that are long header and the short header. So as you can see on the left side, there is a long header packet. At the start of the connection, it uses the long header packets because more information is needed at the start of that thing. So this includes the thing like connection IDs, and the version information. So as you can see, there is the bit 1 and the fixed bit and the reserved bit 2 for the packet type 2. After that, there is a reserved bit for the version, which is 32 bytes. After that, there is a destination and the connection ID, source connection ID, packet number, etc. So after the connection is established, the quick switches to the short header packets. The short header packet are less overhead, so it is lighter and more efficient. So as you can see, there is the fixed header byte, then there is the spin byte reserved, then there is this destination ID and the packet number. So as you can see, and you can compare both of them. So as you can see here in the diagrams, you will easily understand that they are very less overheaded than the long header. So this is a smart decision choice because as the protocol only uses the extra information over there when needed. So once the connection is ready, and it's become simpler and faster to use. So now let's move on to the next slide. So there is some issues given on over there, the connection ID. So the connection ID must be unique so that there will be no survives to IP changes and the IP address changes there. So the next slide is, we are here in this slide we are comparing QUIC with TCP plus TLS plus HTTP2, which is used before many times. So as you can see, TCP is more reliable there and has been used for many years, but it can be slower during the setup and can suffer from head of line blocking. So like QUIC improves on this by reducing the handshake delay and allowing the independent streams over there. So as you can see, TCP also depends heavily on the operating system implementation as well, while QUIC can only be updated more easily in the user space. So the another big difference here is about the encryption. So in the encryption, the QUIC has its own inbuilt feature or inbuilt security from the beginning. In TCP, encryption usually comes from the TLS on the top of that. So if we compare both of them, TCP is older traditional method which we will be following from the many times, and the QUIC is the newer and the most efficient method to use, as its deployment speed is way more faster than the TCP plus TLS plus HTTP2, which we will be using here. So now let's move on to the next slide. So as you can see, the next slide is about HTTP3 and the QUIC. So it is closely linked with the HTTP3. So you can see here HTTP1 we got it in 1997, and HTTP2, which is over TCP and TLS, is getting in the 2015, and over HTTP3, which is over QUIC, we got its standardized version in 2022. So as you can see, the browser may use QUIC underneath to improve the speed and its reliability. So this is very important for modern web browsing because it reduces the delays. So the application layer point of view, when you see it from the application layer point of view, it directly improves how the application behaves or the website are behaving from us. So they connect this connection strongly with an application layer modules in our course. So the major browsers here using this application is HTTP3 are Chrome, Firefox and Safari. So now let's move on to the next slide. So the next slide is about the real world application of the QUIC. So as you can see, many browsers are using many browsers, streaming platform, cloud platform, search engines, DNS over QUIC, and some VPN are using the tunneling solution of the QUIC. So the reason behind this is very simple. It is faster, lower delay, better handling of changing the network condition. For example, if someone is watching the video on the phone and network changes from Wi-Fi to mobile data, we can help keep the connection smoother and simpler. So now let's move on to the next slide. So the next slide is advantages of QUIC. So we had already discussed there are many advantages like lower latency, faster setup, mobile supports, secure by default, independent streams, connection migration, easy updates, improved performance, etc. So these are the overall gives us better speed, better security and better flexibility. So now let's move on to the next slide. So the next slide is about the limitation and disadvantages. So if something is having the advantages, so they also have some disadvantages and limitation as well. So as you can see, there are some limitations and advantages because it uses UDP. Some firewalls or network may block or restrict it. This can cause fallback to other protocols as well. So QUIC is more complex than the simple protocols like UDP itself. So it handles security, reliability, stream control together. So implementation becomes more complicated in it. So the another issue is about the encrypted traffic is harder to inspect and debug because debugging here is very important part, and it is very difficult for us to debug that. For network administrator, that can make a troubleshooting and making the so much difficulty for finding them. So this protocol has advantages, but when it comes with the trade-offs, it also has some limitations and disadvantages as well. So let's move on to the next slide. So here, security in QUIC. So let's discuss about the security. QUIC uses the TLS 1.3, which means encryption is mandatory and is built in that. It is not something added later on or the added after some time. It is from the beginning to the end. This protects the data right from the beginning of the connection to the end of the connection. This also means the data is harder to read, or while it is moving across the network, it is very harder to encrypt or decrypt that. So QUIC includes authentication and integrity protection too here. So in simple words, you can say that QUIC is designed to be secure by default, not secure as an extra option. So security threats and mitigations are there as well. So the security threats are attackers replay zero RTT data to duplicate the request from there. So one of the major example is replay data, especially when the data is on another risk. If we are using UDP based abuse, so such as reflection as amplification attacks, there are also privacy concerns as well. So to reduce these problems, server uses address validations, token checks, careful zero RTT use, connection ID rotation, and rating limitations there. So in the next slide, we will be discussing about the scalability of the QUIC. So the QUIC is so much scalable that it means it is more efficiently when there are many users and many connection at the same time. This is important for the larger slides and the website, cloud services, content delivery networks, connection IDs, help with load balancing, and the user space implementations help with the faster and the more reliable updates there. So when we think about the larger internet systems, QUIC is very practical choice because it supports growth and performs at the same times. So let's discuss about the another things. So the main important thing here is the Wireshark setup and the capture. So this is our practical part. We will discussing this part in the practical session as well on the video or the part 2 of the video here. So this is the currently part 1 of our video. In the part 2 we will be discussing about the practical terms. We will discussing whole Wireshark capture of the QUIC. So here we will be discussing about the theory concept. Then in the practical session we will discuss about the practical concept as well. So here I had used the Wireshark to capture QUIC traffic for this task. So Wireshark is a packet analysis tool that lets us to see what is happening on the internet in the real time. So to focus on the QUIC packets, we had set out the filter to the QUIC, or we can set it out to the UDP port is equals to 4 because QUIC uses the port number 443 of UDP. So this is the practical part. We will discuss it on later on as well in the part 2. So this is the theory from my side, so you can be better implement, so you can have the better overview in the part 2 as well. So the next slide, I had taken the screenshot from there in my Wireshark. So here you can see as well the everything every detail about the quick here. So you can see the first thing you notice is the traffic is going over UDP, not on the TCP. This is one of the key signs that that this is the quick. We can also see the ports like 443, which is commonly used for the secure web traffic. After that, the packet list shows initial packet, which means the connection is still starting, and when I open the details I can see things like connection ID, crypto frames, etc., which we will be discussing in the part 2. So another important thing here is we do not see normal things like TCP three-way handshaking, because we are using because the quick works differently and starts way more faster than that. So let's discuss about this in later on. So this is from my side. So while concluding this, QUIC is a modern protocol that improves internet communication in way many more things. It improves delays, reduces delays, improves securities, supports connection migrations, and works well with the modern application. It is very important because it supports HTTP 3 and helps power the generation of web traffic as well. So this is from my side from in the part 1. Thank you for listening me. So thank you, have a nice day.